and welcome to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you, as you may have expected from the Smash News Network, least busted name in news. And thanks for tuning in. That's the past 24 hours of the closest star. And if you're tuning in for the bucolic imagery of it, or perhaps the frenetic imagery, then make sure you leave us a comment. Perhaps even press the share button and tell your friends and foes about the channel before it blows up in a spectacular fashion. No, not the sun, the channel. The sun's a lot more stable than most noobs on the internet seem to think it is. So, anyway, there's another series of images from the SDO. We're showing some more wavelengths tonight that we don't normally show. That's the 60-minute running difference, 171 angstroms and 193 angstroms from Solar Dynamics Observatory. How many sunspots do we have? I don't know, like 130? That's at least on the visible side of the solar disk. Here we've replaced the 193 angstroms with 335 angstroms, another species of ionized iron. That is iron star. And let's take a look at sunspots for a brief moment. Again, we have about 130 sunspots in the Earth-facing portion of the solar disk. How many are on the other side? I have no idea. I don't try to count far-side sunspots. That's just ridiculous. It's hard enough to keep track of what's going on the Earth side. So there you go. Colorized magnetogram. And we do have at least one or two new groups in the southeastern limb, I believe. So, but we'll show the high-res imagery of that here later in the video. Let's go over volcanoes. Luotobi. Oh my dear God, it's Luotobi. Creating some new real estate there. Quite a rowdy volcano it is. So anyway, here's the list. And I'm just going to let that scroll. So the Isle of Flores is the isle on which Luotobi is located. Popocatépetl, 23,000-foot ash plume over central Mexico there, and Nevado del Ruiz, 21,000-foot ash plume. Sabancaya, 20,000-foot ash plume. And let's get to earthquakes. So earthquakes, those are the past 90 days of earthquakes. And we just had a big one come in while we created the video, while we did show prep actually. A 6.4 near Tonga. Now it was at depth, which means just about a 0% chance of a tsunami from that 6.4 magnitude earthquake there, located in between Tonga and Samoa, kind of. And by the way, that is one of the world's most fantastic New Year's Eve spots. American Samoa, folks. Go to Pago Pago for New Year's Eve. The international date line is like this or something. And so, yeah, highly recommend it. But that's where the largest quake of the past 24 hours happened. Here are the rest of the 5 and greater magnitude quakes, and not too many besides that. Oh, there was a foreshock there. Look at that. Just to the south of it. And then Sandwich Islands. South Sandwich Islands had a 5.3. Only about 20 minutes later. So 5.8 in the Southwest Pacific, and then a 5.3 in the Southern Atlantic Ocean, 5.7 in the Southern Atlantic Ocean, a 5.0 in Mexico, and then a 5.0 north of the main quake in Tonga, and then a 5.2 in Indonesia, and then finally the 6.4. The largest quake of the past 24. Next, we'll take a look at, oh my God, where have I? Oh, I've reappeared. All right. So, hey, I'm back. Hi. And what's next? Things are next. So here they are. Not that. Not even that. Let's get different things. Yeah, different things. Some more solar imagery, shall we? Just kidding. It's a space weather dictatorship over here. And remember, folks, a benevolent dictator is far superior than a democratically... A benevolent dictator is vastly superior to a democratically elected tyrant. So just putting facts out there, folks. Just putting facts out there. So lots of filaments on the solar disk right now, the Earth-facing portion of it. And shout out to Smash staff for tolerating, well, I won't tell you what she's tolerating, but let's just say it might have something to do with my fist and your face. Next, the 10.7 centimeter radial flux, which is at a kind of a low level now. 160, I think, something. 160, I don't know. Something like that. What is it? 162. There you go. 162 is the radial flux. There's the 1 year graph. The red line is the sunspot number. And here's a space weather enthusiast dashboard. And guess what? Nothing exciting in the space weather forecast. I tend to agree. There it is from NOAA. Here's our Earth's magnetic moment from space for the past 4 hours. Pretty uneventful. The sun is withholding plasma, folks. How dare you leave a comment specifically to the sun and say, hey, El Sol, why are you withholding all of that plasma? We need to see the aurora here on planet Earth, so what's up with that? And if you're frightened of El Sol, anyway, there's Earth's magnetic moment from the ground for the past 4 hours as well. If you're frightened of El Sol, you may want to consider the fact that it is the source of, most of the energy on the planet. Most of the life on the planet is largely can thank the sun for it, so it might not be that spooky. Just saying. Anyway, KP index is at 2.0. 2.0 is the planetary KP index, an average of global geomagnetism. Solar wind data shown here as, what do you got? There's ACE. Very diffuse and kind of an average, very diffuse solar wind, but pretty average as far as its velocity. So it's not slow, it's not fast, it's just average. And but it's very diffuse at the ACE. As far as at the Discover, much denser, about 10 times as dense at the Discover, and also quite a bit faster there at 57 kilometers, about 53 kilometers faster or something at the Discover. So, and it looks like kind of a weak and sputtering coronal hole high-speed stream to me. If you disagree, let us know in the comments. Shout out to those of you who are able to forecast space weather. And all of the channels who try. All of the channels who try to forecast space weather. Shout out to you dudes as well. Cheers. Next, the GOES magnetometers. There they are for the past 3 days. Not very exciting. No space weather storms there. No geomagnetic storms, etc. And let's get to the top view ecliptic plane field plot. So there you go. And Earth is still in a North Pole sector. South Pole sector likely to arrive sometime around tomorrow's daily space weather video. So, but at the moment, North Pole heliospheric magnetic sector. No, you can't feel the sector boundary crossing. Next, the line of sight field plot. And what do we got? The photosphere in grayscale, B field in blue, and polar fields in red and green for south and north, respectively. Red is south, green is north. And so that's the situation for the solar fields. Quite a lot of magnetic organization on the Earth side of the solar disk as we ramp up and up and up to solar maximum. Here's our line of sight coronal hole plot. And there you have it. Let's look at coronal holes from the SDO. So there you go. There's another 24-hour video for you, courtesy of Solar Dynamics Observatory, viewing 211 angstroms, part of the electromagnetic spectrum, in the extreme ultraviolet portion. The emissions of highly ionized iron gas is what that ultimately is. And before we get to sunspots on there, let's take a look at sunspots from Rob. There you go. So sunspot number is at about 132, something like that. 130, 132, somewhere in there. 132 is a sunspot number. And there is the flare probability monitor. And frankly, the likelihood of large flares isn't really that high. So let's take a look at sunspots here. Here you go. There's SDO magnetogram plus 171 angstroms, 60-minute running difference. Very nice. Very nice. Here's magnetogram all by itself. And not a lot of changes happening there for the past 24 hours. Things remaining rather stable. No major shifts in magnetic fields. And here's SDO continuum with the 171 running difference. And here's just continuum by itself. Several sunspots there with umbrae larger than planet Earth. So lots of activity. About 130 plus sunspots right now on the Earth side of the solar disk. And several sunspots likely on the opposite side as well. We don't cover that portion because it's already complicated enough covering the Earth side of the solar disk. Moving right along to the energetic particles and solar flares. No energetic particles and no major flares. Just a declining X-ray flux. So it's back down to a B9.9 X-ray flux. And only C-class intensifications have happened in the past 24 hours. Largest flare was a C5. Let's see if we can find where it was. I'll bet it was the southwestern limb, my favorite spot for a large flare on yesterday's Daily Space Weather video, but let's verify. What the heck? What time was it? It was at 4 o'clock this morning. I don't know. Can anybody tell me where that flare came from? Not sure if it was the southwest, but whatever. I'm over it. And let's move on to a star chart. Don't chart, because that would be bad. That would be an unfortunate thing. So don't do that. But there's a star chart. And definitely don't chart light, all right? Especially if you're a content creator. Do not chart light, okay? If people remember the past and you try to convince them that the past happened differently than it really did, you destroy your own credibility. They don't join your cult. They tell you you've chart lighted. Chart lighting, the perfect metaphor for attempted gaslighting. I'll just leave that up to the imagination and continue on. So there's our star chart. Here is our solar system forecast. That's where things are today. Let's advance that. Whoa, my God, dear God. Let's advance that 1 week. That's where things will be in a week on the 25th. We'll be right near a full moon or something, and I am going to show you the astronomy photo of the day next. And thanks for tuning into the Smash News Network. Least busted name. In news, here is the There's the astronomy photo of the day, apod.nasa.gov. It's the aurora over some location. And where? I don't know. Northern lights from the stratosphere. So nice, being photographed from an aircraft at very high altitudes, apparently. Anyway, apod.nasa.gov is where to get that imagery if you want to take a look at it yourself. apod.nasa.gov. Next, coronal mass ejections. That's what's been blasting off, and that's 80 frames from today, January 18th, 2024. Sup with that. Doesn't look super exciting to me. Let's take a look at LASCO C2 and C3. That was just the C2 in the difference imagery. Here's C2 along with the zoomed out C3 on the right in blue. And to quote Stuttering John, let's take a look at our custom coronagraphs. Stuttering John Melendez, everybody. Make sure you tune into his podcast. You can hear quotes as riveting as and others. So those CMEs aren't earthly directed, I don't think. I see well, there might be a component. Oh, what do we got there? There's a thing? No. That's not earthly directed. Pretty cool CME, though. Check it out, right up there in between the polar region and the northeastern limb, you could say, right there. Very nice, very nice. I don't think it's earthly directed in any capacity, but it's still pretty cool. And you can also see the hider flare happening there, right at the end, right there. Right, watch, right at the end, right there. You see that brightening? That's called a hider flare, and we cover it regularly on the channel. And it's time to move to solar filaments because we have to get to meteorology, and there are plenty of weather alerts to cover. So let's blast through. We don't want the video to be too lengthy. We don't want the video to be too lengthy. So anyway, there are filaments. Here's a slightly more zoomed in view, and dag, we got some major filaments. So some of these could use names. Follow the hashtag name that filament over on x.com/smashomash. Next, the last couple of hours from the GOES 16 SUVI. That's what's going on. We got a crown prominence. Somewhat of a crown prominence at both poles. And let's move on to our bonus feature segment. So first of all, we got satellite charging hazards, and they are minor surface charging hazards over places like India and the northwestern Indian Ocean, also the Middle East and northern Africa. There you go. That's what's going on with charging hazards. Ta-dow! Or something. Next, the GOES X-ray flux for the past 3 days, and that's the electron flux, rather. The GOES electron flux, folks. Relativistic electrons at the level of the ionosphere. Here is the 1-year graph, and we're having an electron shortage. Also, the sun is being a plasma miser. So again, make sure you leave comments directed to the sun in our comments, as many viewers are convinced that the sun watches our videos. Next, relativistic electrons here in the forecast model from NOAA, expecting a slow decline in electron flux. So, yeah, I'm not so sure. I think some of those estimates might be wrong. We'll see what happens in a couple of days. Next, we'll show the layer where it's measured, the F layer. Oh my dear God. Dear God. The F layer. Here it is, folks. So are there major anomalies happening in the ionosphere? Not really. Not really. No apocalypse is forecastable via this data. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. And nothing too exciting happening up there. It's nominal in the ionosphere. We'll also show the WAM, or whole atmosphere model. So there's that. Total electron content is free electrons all the way from ground level to your GPS satellite. That's on the left. Maximum usable frequency is the radio frequencies that you'll be able to use to refract radio signals back down to the ground. That's what's going on with those images. And we'll close out space weather with the latest. Is it the greatest? I don't know. It's just the latest. So there you go. And that's what's happening. That is what approximately 130 sunspots looks like. Let's get to meteorology. And we're looking at one of the windiest places in the world, just off the tip of Greenland. Dag, that is berserk, folks. Look at that. Look at that. That is berserk right there. Look at that. We got hurricane force winds there, just south of Greenland in the wintertime. That is not a place to be on a Viking longboat. I mean, imagine what the waves are like. How about some 11-meter waves at 36 foot? You want to be on an open-top boat in 36-foot seas, folks? Be my guest. I'll pass. That is somewhere in between what I think is fun and what I think is scary as hell. But that's some of the world's strongest winds there. Anyway, let's switch to our regularly scheduled meteorology segment. These are surface winds of the east. These are jet streams. Jet streams of the central world. Surface winds of the west. And the jets. Clouds and fog. Here's me telling Smash staff to shut up and not be on the recording. Just kidding. Here's the eastern portion of the U.S., basically the portion of the U.S. east of the Mississippi Valley, mostly. And lots of weather right in the past week or so surrounding the Great Lakes, so that's why we're showing that. And here's our windy.com map showing precipitation type. About half the U.S.'s precip right now is rain. The other half is snow. So that's what's going on. Precipitation type there, one of the many awesome features of windy.com. If you want to follow nitrogen dioxide, yeah, they got that covered. Tidal currents, they got that covered. What about rain and thunder? They got that covered. What about icing severity? They even got that covered. Anyway, here's our weather.gov map, and weather.gov is the National Weather Service's homepage, so there are the warnings for the U.S. We'll scroll down to show the full 50 states and the key. If you've got your location lit up, the place to be, perhaps, is weather.gov to get your warnings, and here come your forecasts. So there's a lower 48 forecast for 72 hours based on a GFS model. Pressure and precipitation are what are repped. Next, accumulated positive snow depth change in inches. So some heavy snow coming there to some isolated places, especially West Virginia, parts of northern Indiana, Oregon, and Washington will get the heaviest snow in the U.S., but also some heavy snow there for Smash Staff's mom in eastern California. Next, temperature anomaly in degrees Celsius. 72-hour GFS model. As cold snap number 2 will encompass the east. A short respite and then boom, cold. Blammo, the jet stream forecast, 72-hour GFS model. the 250 millibar winds. The real driver of your weather. Is it contrails? Is it chemtrails? Is it cloud seeding? Is it HARP? Is it some stuff like that? No. The jet stream is moving systems, for the most part, in terms of cold air going south and warm air going north, and most of the weather going west to east. The jet stream, folks. The real decider of your weather. Anyway, next is lightning. There's lightning for the past 10 hours. Here's lightning for the past, I think, 1 hour from lightningmaps.org. And we have some strikes in the Atlantic. Let us know in the comments if you have a boner over it. Only 15 strikes per minute. That's a very low level of lightning. Also, don't forget to subscribe to Eugene the Philosopher. And by the way, you could submit a question for next week's Ask a Particle Physicist segment if you like, because this week's has already been asked. What will it be? Well, that's for you to find out the hard way. And also keep in mind we're doing something on Saturday. So make sure you tune into the channel on Saturday. There'll be a new playlist. I'll just leave it at that. But make sure you subscribe to Eugene the Philosopher in the meantime as he approaches 600 subscribers. If you want to submit a question, do so at the forum, smashomash.com/forum. In the General Science Forum, there is an Ask a Particle Physicist segment in there. And I'm not going to show you what this week's question will be because it is represented there. Anyway, we'll close out today's Daily Space Weather video with the latest Doppler, the latest clouds and fog, and the latest water vapor. The 3 maps that will teach you how to forecast the weather for your friends and foes. Impress your friends, frighten your foes by forecasting the weather. And there's some coming to Pennsylvania once again. I'm glad I didn't put my windshield wipers down because there's more snow coming. So there's the clouds and fog map depicted by 3.9 micrometer infrared radiation. The shortwave radiation map on Interactive Weather Satellite Suite. And there's the water vapor map. So, yeah, that's what's going on. You can see a second wave of cold air there blasting down through Montana and the Dakotas from Canada. That's cold snap number 2, starting to arrive in the U.S. states now. Here's your recap. U.S. Doppler radar depicting vertical motion of air column air. Here is actually water droplets in the air column. Here is infrared radiation from clouds and fog from space-based interactive weather satellite. And here is water vapor. When your Doppler is unclear, use that map or this map right here. Anyway, it's time to close this thing out. So until tomorrow, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. While I go back to the bunker again, I guess I'll take the ladder tonight so I don't have to splat in.